to a set R, which we call the range, is a rule that assigns every element in D to a unique element in R. So the word unique, I think most of us know what it means, but really the definition of unique would mean only one. Like if somebody is unique, you would say, oh yeah, they're kind of one of a kind, right? But the verbatim definition is only one, and that's where we are talking about only one output. Does that make sense? All right, so I was talking about domains, and the domain are really the possible inputs. Possible inputs, or possible x values. Now, domain and range were something that were actually very hard for me as a math student, and they didn't make sense to me unless I looked at them graphically. So I tend to explain it more graphically, but I envision the graph in my mind and then I look at the function as well. On a graph, if their inputs are x's, where do you think you're looking to figure out the domain? From left to right, yeah. So I'm going to write that down. All right, so let's do some work with domain in a minute. So the first one I'd like to do is f of x equals the square root of x plus 1. Okay. So, did you guys do interval notation last year? Don, do you remember? That's a long time ago. I think we might have done a little bit of an algebra 1, actually, but I'm going to just describe it in words, and then I'm going to do interval notation. Interval notation actually just describes it from left to right with numbers. So I'll show you how that works. It's pretty easy. Actually, when we introduced it in Algebra 1, the students like to do it that way better. But that's how our book describes numbers, okay? In your mind, square root, what sometimes is an issue with the square root? Like, what kinds of numbers do we not take square roots of? Negative. Okay. And so the smallest thing that I could put in here would be, if I would evaluate the whole expression, would be if this whole thing was 0. We can take the square root of 0, right? Okay. But we can't go any less than that. Agreed? Okay, but if I put a 0 in here, if I put a 0 in for x, what does this actually become? 1. Can I take the square root of 1? Yeah, okay. What's the smallest thing I can put in here then? -1. Because if I put a -1 in here, I would have a 0, and I could, all right. But if I would go -2, do you see how that would be a problem? Okay, so for the domain, you might have written it this way: x has got to be greater than or equal to -1. Is that how we wrote it last year? Okay. Let me show you an alternative way of writing it. If we think on the graph from left to right, the graph starts at -1 and it goes forever. And so in interval notation, the way we write that is with a hard bracket, -1, comma, infinity. And that just means we use a hard bracket when it touches it. See how it can be -1? And we use a parentheses when it doesn't touch it. Do you ever get to infinity? No. Okay. All right, so in my head, when I see this, I know, you don't know this yet, but you will in a couple weeks. I know that this is the square root curve moved left 1, and this is why I say I like to look at it graphically. You don't know this yet, but if you would put it in your calculator, this actually, okay, that's what the curve looks like. Left to right, do you see there's nothing going on over here? Where does it start? Which x value? -1, and it goes forever. We'll get to range in a second. All right, let's do another one. G of x equals, how about x over x minus 3. So when I have things with fractions, I like to look at them piece by piece, okay? Can I put anything in for the function x? Can I put anything I want in there? The top. Yeah, okay. When we're dealing with a fraction, what kind of sticks out to you as a restriction or something that we can't have? We can't have 0 as a denominator. So I can put anything into this except what would make the denominator 0. What would that be? Good. So the way I would describe the domain is, this was going with this first one, all real numbers except x cannot equal 3. Okay. Did Mr. Spaulding last year use like a backwards E when he was he did? No? Like he did this x as an element. Do you remember that? No? Okay, never mind. I was going to say you could use that if you wanted to. Let me show you what it looks like in interval notation. If you're thinking about this graph left to right, and I'm not even looking at it right now, I know it can be everything except 3, and so what happens is that it goes up to 3, then there's a break, and then it starts after 3. Is that kind of making sense? All right, so in interval notation from left to right, it goes from -infinity to 3, takes a break because it doesn't get there, so use the parentheses. That is a union with 3 to infinity. These are just two different ways of writing domain. If you're getting domain, but you're not getting this, I am not concerned yet. You're going to pick that up. If you're getting the domain part, but you're not like, what? What's the parentheses business? That's okay. You still understand domain. It's just a way of writing it that we're going to keep working on. All right. Let's do another one. See here. How about the function x squared plus 7? Any issues there? Tell me your thoughts about that. Anybody think they know the domain of that? Yeah, it could be anything, right? Are there any restrictions on an x squared? No, you can put anything you want. It's not like I have a fraction here where I can't have a 0 on the bottom. It's not like a square root. So how do we describe that in math if it can be anything? All real numbers. Good. So you saw I did that up there. There is a symbol that means all real numbers. Does anybody know what it is? This R business. That symbol, have you seen that before? Yeah, that's the symbol for all real numbers. Like if you looked at a textbook that was, actually I don't know if they have it in ours, but like a college textbook, they would. And then Aiden, you said negative to positive, is that what you said? And that's the way you would write it with interval notation. It is negative infinity to positive infinity. There's no breaks in the graph at all. Okay. You guys are good. Now, let's give you a tricky one. Oh, by the way, I did want to show you the graph of this one. Hold on. So you could see it. Okay. This is the graph of B. And so, do you see the break at 3 there? X equals 3. And I hope then that makes sense. This negative infinity to 3 describes this part. And this 3 to infinity describes that part. So describing the different parts of the graph. Okay? All right. Last one we're going to do. And then I'm going to talk a little bit about range. Unless your brain is fried, then I won't. All right, what was I? H of X. I don't know. L of X. I'm just making up different ones because they're all in the same example, so they shouldn't be the same function. How do I do this again? Oh, yeah, I know. All right, 8 over 8x over x plus 5, this is all on the bottom, over the square root of x minus 2. Okay, now before we freak out about this, let's, deep breath. Okay, let's just look at it, I say piece by piece. Is anything an issue on the top? No. Okay. If it was just this, what would you tell me x cannot be? Negative 5. Okay. And then if I'm looking at a square root, now the square root is on the bottom, so normally square roots have to be 0 and above, correct? But we're going to take out the 0 because it's on the bottom. So would you agree then for this, it's got to be bigger than 2? X has to be bigger than 2. Okay. So if I was describing this, I'd say all real numbers except negative 5, and x has to be bigger than 2. I want you to think about that. Does this even really matter? No, graph hasn't even started yet. So even though in our heads we look at that, we kind of say, okay, this cancels out this. So even though there's an asymptote, there would be an asymptote there if that weren't there, this doesn't even start till 2. So it doesn't matter that x isn't negative 5, because this domain kind of cancels that one out. So the domain for this would be real numbers greater than 2. So the way I would write that is x is greater than 2. In interval notation, the way that I've just kind of introduced today, it would be 2 to infinity.